All right, hello everybody. Today is day 3 of graph sketching, and it's going to be very similar to what we've been doing in day 2, which was getting information about our graph from the equation of a function. So we'll still be looking for where our critical points are, our extreme values, intervals of increasing and decreasing, concave up and concave down. We're still going to be getting all of that same information and organizing it in our chart, but this time we're going to have to sketch a graph as a result. So where we've been kind of just sketching the rough behavior of that graph before, now we're going to have to pin down all those values and sketch that graph. So a lot of the steps are going to be exactly the same. Like I said, really the sketch is the only thing new. So to get started, I'm going to kind of go down to 2 colors here to simplify things a little bit. But the first thing I'm going to do is find my derivative and set that equal to 0. And that's going to help us find our critical points. So here we go. First thing I have is f prime of x, and we know that's going to be 3x squared minus 12. And I want to find out where that's equal to 0. So I'm going to go ahead and factor out a 3. So I get 3 times x squared minus 4 equals 0. So we can tell pretty quickly we're going to be 0 when x is positive or negative 2. Okay, and those are our critical points. So we know that'll be some of the information that goes into our table. So the next thing I want to do is find out where my possible points of inflection are. And we know that has to do with the second derivative. So we're going to find f double prime of x, and that's going to be 6x. Nice and easy to work with. So I want to know when that's equal to 0. And obviously that's going to be x equals 0. Now, I'm going to make a note here that this is just a possible point of inflection. Right? We need to check that the concavity actually changes, and we'll find that in our table. So I'm going to put need to check that concavity changes at x equals 0. So we're not going to put that in our information down here quite yet until we double check the concavity actually changes there. But what I can put are my critical points here at positive and negative 2. So I'm going to go ahead and make my table. I've got f prime of x and f double prime of x. I'm on an open interval here, so my far left endpoint is going to be negative infinity. Then I'm going to have negative 2 as one of my critical points. 0 is a possible point of inflection. Excuse me. 2 is another critical point. And then at the far right, we have infinity. So now we're going to fill in our signs. So anything having to do with our first derivative, I'm going to mark in purple. So that'll be my increasing and decreasing. And I expect that that's going to change at my critical points, which are marked in purple. So I'm going to pick something less than negative 2. So if I pick negative 5, I'm going to plug that into the first derivative. So negative 5 squared is going to give me a positive 25 minus 4 is a positive 21. So that's going to be a positive. I'm increasing over that interval. Now I'm going to pick something between negative 2 and 2. So I'm going to go ahead and pick 0 and plug that in here. If I plug that in, I'm going to be negative over that interval, so I am decreasing. And then if I pick something greater than 2 and plug it into my first derivative, I can see that I'm going to be positive. So I'm increasing again. So now I can fill in my intervals of increase, which is from negative infinity to negative 2 and 2 to infinity. And decreasing then is from negative 2 to 2. Now, if I look at concavity, I know that could potentially change here where x is 0. So I'm going to plug in something less than 0 to my second derivative, and that's going to be negative. So I'm going to be concave down here. If I plug in something greater than 0 into that second derivative, I'm going to be positive and concave up. So I am concave up from 0 to infinity, and I am concave down from negative infinity to 0. And now I can check, since my concavity did change at x equals 0, I can go ahead and say that x equals 0 is a point of inflection. So now, we kind of looked at this before. We can really put together the shape of what this thing should look like. So I know from negative infinity to negative 2, I should be increasing but concave down. So I'm going to look like this. Then between negative 2 and 0, I'm decreasing and still concave down, so it's going to take on this shape. From 0 to 2, I'm decreasing but now concave up. So decreasing, but I'm starting to look like I can hold water there. And then increasing and concave up. So really we're thinking of just stitching these pieces together. And we're going to find some y values for these points so that we can plot them in our graph. So I'm going to go ahead and figure out the y value when x is negative 2. And again, I'm going to plug that back into the original equation here. So negative 2 cubed is a negative 8, plus 24 is going to give me 16 minus 5. So it's going to be at negative 211. When I am 0, when x is 0, my y value is negative 5. And then at positive 2, I have 8 minus 24 is a negative 16, minus 5 is a negative 21. So now it's just time to put this all on a graph. So I'm going to draw my axes here. My positive, it needs to go up to 11. I might make that a little longer because I know I need to get down to negative 21. So my x's are 1, 2. So negative 1, negative 2, 1 and 2. And then I'm just going to count by 5 here. So 5, 10, 15, 20. So now I'm just going to plot my points. Negative 2, 11 is going to be about here. I'm at 0, negative 5, I have a point here. And then 2, negative 21 is going to be down here. And so now I'm just going to fit this behavior that we observed here to these points. So I know I'm coming up. Here I'm going to be concave down and decreasing. I changed to decreasing and concave up, and now concave up and increasing. And again, I'm not worried about where these x-intercepts are. I just have my kind of key max and min values, my point of inflection, and the rest is just a rough sketch. So that would be it for number 1. So now we're going to go ahead and look at number 2. And we're going to do the same thing. So here's number 2. My function is h of x is 1 over x plus x. So again, our first job is to find those critical points. So h prime of x, if I take the derivative, I'm going to have negative 1 over x squared plus 1. And so the first thing I want to do is find where is that equal to 0. So I have 1 over x squared equals 1, which means x squared is 1. So x is positive or negative 1. Now remember, we also have to check. We said the critical points are where the derivative is 0 or undefined. I know my derivative is going to be undefined when x equals 0. So that's going to give me another critical point. So my critical points are negative 1, 0, and 1. So now we're going to find our second derivative, which is going to give us 2 over x cubed. That's going to drop off. And so I want to know where that's equal to 0. But obviously this is never going to be equal to 0. So the only thing I can look at is where it's undefined. And again, h double prime of x is undefined when x equals 0. Okay, so now we've got all that information, so we're going to go ahead and make our table. And so again, I'm going to set it up. I have my derivative and my second derivative. And we're going from negative infinity. Then I have my critical point, -1. My second derivative is undefined at 0. Extend my table here. Another critical point at 1. And then infinity here. And so now we're going to fill in our table. So if I'm looking here, I'm going to pick a point less than -1, and I'm going to plug it into my derivative. So if I pick -2, I'm going to get -2 squared is 4, so I have -1/4 plus 1. So I'm going to be positive. I'm increasing there. Then on my next interval, and actually this was undefined when x equals 0, so I do need to check both between -1 and 0 and 0 and 1. So let's do -1/2. So if I plug in -1/2, I'm going to get 1/4. 1 over 1/4 is just going to be 4, so -4 plus 1 gives me a negative number, so I'm going to be decreasing. If I plug in a positive 1/2, I'm going to get the same result. 1/2 squared gives me 1/4. 1 divided by 1/4 is 4. So -4 plus 1, I get a negative number, and I'm still decreasing. And now if I plug in something bigger than 1, let's say 2 again, I'm going to be -1/4 plus 1, and so I'll have positive, so I'm increasing over that interval. Now for concavity, I only have to check on either side of 0. So if I plug in -1, that's going to give me a -2, so I'm going to be concave down here. If I plug in something greater than 1, I'm going to be positive, and so I'll be concave up. So let's see. I'm going to go and grab my y values for the function, because I know something funny is happening where I'm undefined. And actually, using what we know, we can already see, hopefully, that we have an asymptote at x equals 0. So -1, if I plug that in, I get -1 plus a -1 is going to be -2. Here I'm undefined. We're going to have an asymptote there. If I plug in 1, I get a positive 2. And if I look at my behavior, so I know I have a vertical asymptote here now. Over the interval from -infinity to 0 up to that asymptote, I am increasing but concave down. And then I'm decreasing and still concave down. On the other side, I'm decreasing and concave up, and then increasing and concave up. So I'm getting a picture of what this graph looks like. So now I'm going to be increasing from -infinity to -1 and 1 to infinity. Now I'm decreasing really over this whole interval from -1 to 1. However, because I'm undefined at x equals 0, I can't really have that in my closed notation. So what we need to say is we're decreasing from -1 to 0. I'm open there because 0 is undefined. And then I'm also decreasing from 0 to 1. So we have to exclude that point because the function does not have a value at that point. For concavity, we're concave down, from -infinity to 0, and concave up from 0 to infinity. Now, for my points of inflection, normally we would say we have a point of inflection where our concavity changes. However, since 0 is not defined, we don't have an actual point there, so our points of inflection, we would say, are none. So I'm going to go ahead again and sketch my graph. So I've got -1 and 1. And let's see, we go up to 2 and down to -2. So -1, -2 here, and then I've got 1, 2. And again, I'm just going to do this in blue so it stands out. I know I have an asymptote here. And so my graph, again, and I don't know the exact shape, and for now that's okay. We're just sketching the basic characteristics of this graph. So I know coming from -infinity, I'm increasing and concave down up until this point, and then I'm decreasing and concave down again. On my other side, coming from 0 here, I'm decreasing and concave up, and then on the other side of 1, I'm increasing and concave up. So I would look something like that. So that's a basic sketch. Again, it's not going to be perfect, but it's going to show us the general shape of that graph. So that's it for day 3, and that's what we'll be practicing with tomorrow.